I'm Dylan Dalida, your host. I am a grade 7 student in Philippine Science High School who is interested in mathematics. This is the first episode of Math Quest labeled Factoring. Today, I am going to teach you factoring techniques that your teachers won't tell you in school. First of all, let's see if you're okay with the basics. Let's see if you know how to factor trinomials. Now, this trinomial is a trinomial with degree 2. Now, notice that we have to find factor pairs of 6 that sum to negative 5. So the factor pairs of 6 are 1 and 6, 2 and 3, 3 and 2, and 6 and 1. Now notice that each of these two has a sum of 5. But since the 5 is negative, our answer is a minus 2 times a minus 3.
Let's see if you've mastered the basics. Factor the following trinomials complete.
Now, let's get on to some more advanced topics. I'm going to show you how to complete the square. This is something your teacher might have told you about in school, but he never really discussed it properly. We are going to try to convert an equation into the form x plus b squared plus a. Now, k and a are not variables. They are real numbers and we are going to replace them with real numbers. These can be negative. I'm just going to give you the answer right now. X plus 4 squared minus 1. Now, why are we trying to do this? This is going to be because that it has a lot of functions. For example, in Math 2, when you're going to graph parabolas, this is a much easier way to do it. Also, you can factor this as a difference of squares. Did you notice that? Look at this. This is a much easier way to do this. And there we go. Now I am going to show you how I derive the answer. Recall the perfect square trinomial rule. Quantity x plus k squared is equal to x squared plus 2kx plus k squared. We are going to try and find a k such that 2kx is equal to 8x, so that we don't have to add or subtract any x's at the end. Solving, we have 2kx is equal to 8x, 2k equals 8, and k equals 4. Great. So now we have x plus 4 squared. But if we multiply this out, we get x squared plus 8x plus 16. And that's sad because these two are not equal. That's okay, because we can just subtract a 1 at the end. This is so that it becomes x squared plus 8x plus 15. And that is the original equation. Let's try one last example. Now, look at this. We are now going to try to find a term 3, such that 3x is equal to 2kx. We've already got this. But, if we solve this, we have k equals 3 halves. And this is a fraction. And that's also sad. It's okay, we'll get through this. Now, when we multiply this out, we get x squared plus 3x plus 9 over 4. And that's sad. But at least we have a 5. So we can just add this, but it's a fraction, so it's quite messy. we have to find a fraction such as 9 fourths plus x equals 5. Now if we solve that, we get 11 fourths. And then if we add this, we have our answer. X squared plus 3x plus 5. Now this answer is quite messy, but it's still useful in higher math.
Let's see if you've mastered the basics of completing the square.
How did you do? I'm assuming you got all 3 right. Great job. Now, let's go on to some critical thinking. This is the hard part because you have to be a bit creative. Look at this. Is this factorable? No? No? Yes, it is. It is factorable. Notice this. A to the 4 is equal to quantity a squared squared, and 4b to the 4 is equal to quantity 2b squared squared. Recall the perfect square trinomial rule. Now we're just going to replace the a and b with a squared and 2b squared respectively. If we multiply this out, we get a to the 4 plus 4a squared b squared, be careful with the signs and the products, plus 4b to the 4. Now, let's look at this. We can just subtract this at the end so that we get a to the 4 plus 4b to the 4 back. A squared plus 2b squared squared minus 4a squared b squared is equal to a to the 4 plus 4 to the 4. Now, notice this. Four a squared b squared is equal to quantity 2ab squared. Now notice that this is a difference of squares. We can just factor this as a squared plus 2ab plus 2b squared times quantity a squared minus 2ab plus b squared. This is equal to a to the 4 plus 4b to the 4, and that is our answer. Did you know that this factorization has a theorem? It's called the Sophie-Germain theorem, and that's quite cool. Let's go on to our second and last critical thinking example. 26x cubed minus 3x squared minus 3x minus 1. This doesn't look factorable, but it is. Look at the coefficients of the last 3 terms, 3, 3, 1. What does that remind you of? Yes, it reminds you of Pascal's triangle. Let's try x plus 1 cubed. Notice that this is equal to x cubed plus 3x squared plus 3x plus 1. Let's try adding this equation to this equation. So we have this equation plus x plus 1 cubed is equal to 27x cubed. Notice that these two are both cubes. Now notice this equation. We can just subtract this, transpose it, so it will become 27x cubed minus x plus 1 cubed. That's also here. But notice that 27x cubed is a perfect cube. It's equal to 3x cubed. Now we can subtract x plus 1 cubed, and we can factor this as a difference of cubes. We have 3x minus quantity x plus 1 times 3x squared plus quantity 3x times quantity 3x plus 1 plus quantity x plus 1 squared. Now when we multiply this out, we get 2x minus 1 times quantity 13x squared plus 5x plus 1. And that is our answer. Did you know that this method of splitting 26x cubed into x negative x cubed and 27x cubed has a name? This is called the magic method. It's not actually called the magic method, but everyone calls it the magic method because it's magic. And that was the first episode of Math Quest. There are more episodes to come. I hope you enjoyed them. Thank you.